Good morning, everybody. So today we're going to be talking about types of reactions. So what you're going to need is your page 11 notes, which talks about the 5 types of chemical reactions, okay? So the 5 types of chemical reactions, I'm just going to switch the view here, so that way you can see. We've got the synthesis, okay? The synthesis would be kind of like two things being added together. The example given in class is kind of two people becoming a couple. We've got decomposition. The example would be the couple breaking up. So that would be a compound splitting into two different things. Single replacement, that would be one, like a metal and an ionic compound, kind of switching places. So you got a guy and a couple, and then suddenly the guy takes the girl and the other guy is left alone. So that's an example that you can kind of think about. And then double replacement is like you got two couples and then they just sort of switch places, and then maybe everybody's happy, or maybe they're just two best friends and then suddenly the two best friends are different two best friends. And then finally we got combustion, and that's when we got a carbon and hydrogen compound, and in the presence of oxygen, it burns, and the products are carbon dioxide, water, and energy. So what I'm going to show you are some examples of each one, okay? So the first one, if we go to page number 13, okay, it's got the procedure. I'm going to get into the light. All right, so it's got the procedure. So it says, first thing, you want to burn the candle. So I'm going to light the candle with a match, run the match under water before throwing it away, and then I am going to write down at least 3 qualitative observations on my chart on page number 14. So first, on page number 14, you want to make sure that you have all of your reactions written down. You should copy these down from page number 12, which we did together in class. Okay, so I've copied down my reaction from page 12. So I've got C25 H52 plus 38 O2, and it makes 25 CO2 and 26 H2O. So basically a carbon and hydrogen compound in the presence of oxygen is going to be burned, and it's going to make some CO2 and some H2O. So in case you're wondering, this right here, this is a candle. I'm going to light it with this little lighter instead, okay? So you can see a flame, there's oxygen in the room, so it's burning. So some observations we can see. Okay, the wax is starting to melt, there's a flame, it's hot, and then when I blow it out, you can see there is some smoke. There's some gas that's been produced. Reaction number 2, I've got magnesium and HCl. Okay, so the procedure, it tells me to put 1 squirt of 3 molar HCl in the test tube provided. So I've got a little test tube. Add 1 piece of magnesium ribbon. After a couple seconds, put a flaming splint into the top of the test tube. Write down all qualitative observations into your chart. All right. So here we go. Here's my test tubes. I'm going to start out by first putting the 1 squirt of HCl. I'm going to use forceps to add the magnesium, 1 piece of magnesium ribbon. Okay, you can see that it is bubbling. Alright, so flaming splint is this guy right here. So I'm going to light it. I'm going to see what happens. First it needs to get lit on fire. Okay. Okay, now I'm going to put it in there. And there was a little pop, Okay? So that little pop. So we've got bubbling, it's hot, and when I put the flaming spoon in there, there was a little pop. I'll do that again because it's still reacting. Get it down there a little bit deeper. You hear that? It's like a little pop. Okay, it only does it once because it's reacting with the gas that's being produced. And if you look at your product, you can see which gas is being produced. All right, so I'm going to clean this up, and we're going to move on to reaction number 3. All right, reaction number 3 is aluminum and copper 2 chloride. Put 1 piece of aluminum into a test tube, and then put 1 squirt of the copper chloride and write down the observations on your chart. So here's my test tube rack. Okay, first I'm going to put the piece of aluminum in there. Okay, I'm going to use my forceps to grab a piece of aluminum, put it in the test tube. I hope you guys all have a lovely Friday after our 2 very long 8-period days. Here at Rolling Meadows High School, we have block schedules, so we normally have only 4 periods per day, not 8, which might be weird to some of you if you're watching this from different schools. Alright, so anyway, you can see it's starting to bubble. The aluminum was silver. I'm going to kind of shake it up. It's bubbling. You can see there's color change of the solution. And there's also condensation on the test tube, which means there's heat being produced. Touch it. It's hot. And you can also see that there is a color change in the metal. It was silver, and now it's kind of a reddish brown. So if you look at your equation, you can predict what metal now is being produced, and maybe what kind of reaction this is. If I started with aluminum and end with a different metal, what kind of reaction do you think this is? Okay. And also my solution, it started out very blue. Now it is going to clear. Okay. My metal started out silver, and now it is a completely different color. Alright, next one, baking soda and vinegar. I need to make 10 milliliters of vinegar, measure it out, pour it into a test tube. I've got a bigger test tube, just in case. So I'm going to use my pipette here to measure out 10 milliliters into this graduated cylinder. Good thing I have long nails because I almost lost my pipette in there. Alright, so I'm going to get 10 milliliters. It's a few squirts. Alright, then I'm going to place it back on the side here. Okay, 10 milliliters. I'm going to pour it into this test tube. Okay, so it's a bigger test tube. And then it says, measure a small amount of baking soda for the first part of the scoopula. So just a small amount. And place it in here. Alright. So it's a very small amount of baking soda. You can see there's bubbling. You can see the level rise. The level of liquid rises, and then it falls. When I feel it, even though there's gas being produced, it's actually cold, it's not hot. Okay? And then it stops. Alright, next we've got iron 3 nitrate and sodium carbonate. We're going to put 1 squirt of iron 3 nitrate and 1 squirt of sodium nitrate. We're going to mix together in a test tube and allow it to settle and write down all of our qualitative observations. So first of all, this is iron 3 nitrate. Observe the color. This is sodium carbonate. Again, observe the color. This is a test tube. It has stuff in it. This is a clean test tube. Let's use this one. Alright, so I'm going to put 1 squirt of each. 1 squirt of that. Stays the same color. And now I'm going to put 1 squirt of this. Alright, so you can see I had 2 clear solutions and allow it to settle. 1 was yellow, 1 was colorless, and now I have this orange solid. Okay. Alright, the next reaction, burning copper wire. We're going to turn on the Bunsen burner. I'm going to use some crucible tongs, take a piece of copper wire, put it in the flame until we see a color change. It's going to be quick. Place it back on the lab bench and turn off the Bunsen burner and write down any qualitative observations that we see. So, Bunsen burner, crucible tongs, goggles, you can see my hair is back. Alright, here's some copper. I'm going to turn the gas on. Going to light the burner. Alright. Ready? Bring it closer so we can see. I'm going to not drop it this time. Alright, so in the flame, you can see a color change. And on the copper itself, you can see a color change as well. Alright, and obviously it's hot. Alright, so you can see on the copper itself. And now the flame is also a different color. Very cool. Alright. Now look at the color of the copper. It's hot, so. Look at the color of this copper compared to original non-heated up copper. Okay? Write down your observations. Alright, so our last reaction is hydrogen peroxide. So we're going to add a squirt of hydrogen peroxide into the test tube and add a very small amount of manganese dioxide and write down our observations. So here's my hydrogen peroxide. Putting it in the test tube. And I'm going to add a very small amount of manganese dioxide. So I'm going to use my spatula and just add a teeny tiny amount. Alright. It got hot. There was a lot of steam. I'm going to try that again, and I'm going to add an even smaller amount of manganese dioxide so you don't see so much black. Alright, hydrogen peroxide. Very small amount. Hot. Okay. So what do you think is happening to the hydrogen peroxide here? Okay. Look at the reaction. What do you think is happening? Is anything happening? Is the manganese dioxide even in the reaction? So this manganese dioxide is what's known as a catalyst. A catalyst is something that just speeds up a reaction. The manganese dioxide itself, it stays black because it's not really involved in the reaction. It just helps speed up what's happening. So when you look at your reaction of hydrogen peroxide going to H2O and O2, this manganese dioxide is just kind of speeding that up. Okay, so that's what's known as a catalyst. Alright, so those are all the reactions. Please write down everything that you see on page number 14, and I hope that you have a great day.